So, all right, ladies and gentlemen, welcome, welcome. So we're looking at problem 23 from last night's homework, page 518, and we are trying to solve this equation. However, we're not going to use synthetic substitution and tables and Descartes' rule and all that. We're interested in factoring this or solving it in some fashion using quadratic techniques. And the first trick, well, this isn't a trick, this is just a generally good idea that you want to do is factor out the GCF whenever possible. So we didn't go over one of these specifically yesterday, but once I do that, I end up getting two factors there, and then I could say either x equals 0, all right, which that's a solution, or x squared minus 3x minus 10 equals 0. And then I could solve that by factoring. So that's 1 and 10, 2 and 5. Which of those subtract to be 3? So that's the 2 and the 5 there, right? So I will have x with a 2, x with a 5 equals 0. The signs are different because they multiply to be negative, and they add to be negative, so the more influential one must have been negative. And then I would have two things that multiply to be 0, so either x plus 2 equals 0 or x minus 5 equals 0. So yeah, so that one was a GCF one. So I would say it didn't quite fit in the batch of problems as well as perhaps the others did. But those would be my three answers. So other questions from the homework? Oh, I got the blurries here. What else we got?
So I have a question on number 21.
Yes.
It had 5y to the 4th plus 7y. So when the second one is not a y squared in that case, which it should have been, that makes it impossible.
Yeah.
Right. Yeah. The issue is you caught the issue is that second term, right? So I mean I could have written as 5y to the 4th plus 7y minus 8 equals 0, and if I tried to pretend that that this was a quadratic, yeah, that was the issue. That if I had y squared here, right, I can't have y squared there. So I need to make sure that whatever plugs in one of those spots is the same thing on both sides. So since I couldn't get agreement there, that was the issue, right? That it didn't work out. So that's why it was impossible. Yeah. Let's see. Other questions?
27. Wait, I was saying 25.
Yeah, 25.
Yeah.
Both, actually.
All right.
Could be cool.
Yep.
25 is going to require a pattern.
Yeah, I found the pattern once I found it. I didn't know what to do with it.
Okay. I might not take this through the whole way, but I'll set it up for us until it's solvable. So let's see. I would subtract 1331 from both sides. And now this is actually factorable by this pattern. The difference of cubes pattern, let's see, is going to be a minus b times a squared plus ab plus b squared. So a would have been b in this case. That's kind of weird. And b would have been the cubed root of 1331, which is apparently 11. Actually, I think a handful of the powers of 11 are palindromes, where they're read the same way forwards as they are backwards. So, I don't know. We're at 121, 121, 1331, same both ways. But anyways. So yeah, so then I would just plug that in here, and I would get b minus 11 times b squared plus 11b plus 121 equals 0. And then I'd set both of these equal to 0. This one, when set equal to 0, I believe is not factorable, and it looks like they used the quadratic formula on it. So that's what had happened there. So I'll just put dot, dot, dot. So yeah, the trick was that, yeah, you kind of had to recognize that pattern, sadly. I like 27, though. 27 is more purely with the concept of what we learned yesterday. So let's see. So we have, we can pretend that this is a quadratic. So what squared minus 8 times what minus 240 equals 0? Oh, that's an ugly equal sign. It's a little better. At least fits to my taste there. So let's see. So what would go in these parentheses? Square root of z. Right? Would fit in both of those because the square root of z squared is in fact z, and then 8 times the square root of z works out. So let's define our variable. U is equal to the square root of z, and I'll be able to solve the quadratic u squared minus 8u minus 240 equals 0. I'm guessing, based on the fact that this has a single answer, the second answer may actually be extraneous. So that may have been the case. So if you had an extra answer, yeah. So let's try to factor this. Yeah, okay. So the factors of 240 that subtract to be 8, there's going to be a lot of them. But 1 and 240, 2 and 120. Let's see, 3 goes into 12 6 times, so 60. Wait a minute. All right. And then 60 times, nope, what did I do wrong? 40 times. 40 times 280, yep. There we go. And then 4 goes into 80 20 times, and 20 times 3 is 60, I believe, yep. 5 goes into, let's see, 16 times 3, was that 5 and 48, is it? We're still not at a difference of 8 yet, so we have to keep going. 6 went into 60 10 times, and 10 times 4 is 40. All right. 7 doesn't work. 8, I believe, should work. 8 goes into 80 10 times. 10 times 3 is 30. See, I've got like this little trick where I just figure out how many times this goes into one of the other ones, and then multiply the scrap by the other factor. And then, because I wouldn't necessarily spot all these that quickly. 9 would not work. 3 went in once, but 9 doesn't. 10 works. 10 and 24. We're getting warmer. That's a difference of 14. 11 wouldn't work. 12 goes into 24 twice. 2 times 10 is 20, and I think that's our culprit right there. I don't know if there may be other ones, but stop there for now, I suppose. So I will have u with a 12 and u with a 20 equals 0. Their signs are different since they multiply to be negative, and the more influential one must have been negative in order to add to negative 8. So that's negative 20, positive 12. So I'll get u plus 12 equals 0, u minus 20 equals 0, 0, oh, yep, 0. There we go. So u equals negative 12, and u equals positive 20. And now we didn't want to solve for u, we wanted to solve for z. So what I'm going to do is take this and substitute it all the way back down here. Nope, not there. All the way down here. And here. Right, so I'll be able to solve the equations. The square root of z equals negative 12, and the square root of z equals 20. And then to solve those, we could just square both sides. And we get z equals positive 144 and z equals 400. Now it turns out when I do a check with 144 in the original problem, let's see if I can fit a check over on the side here. I will have 144 minus 8 times the square root of 144 minus 240. Is that equal to 0? So 144 minus 8 times 12 minus 240, is that equal to 0? 8 times 12, 80 plus 16, 96. 144 minus 96 minus 240 equals 0. I'm guessing if this was plus 96, that would equal 240 minus 240, and it would have worked out. Yeah, what's 144 minus 96? Let's see, that would be 40, and then, yeah, just 40, right? Minus 240. And we end up with negative 200 is not equal to 0, right? So what happened there was that this was extraneous.
48.
48?
Yeah.
All right. Yeah. Thank you. Yeah, negative 48. Oh, yeah. How did I? Yep, that would do it. And then that would have been negative 192, was it? Either way, definitely not 0. Thanks. So, and then if we checked 400, 400 would have worked, but for sake of time, us getting ready for our quiz, I won't do that. Did anyone have any other quick questions on some of the other ones that you want me to at least do the setup for? I don't know if I'd want to necessarily take the time to solve it, though. Anybody? Okay, how about opening the floor to any questions on any of this stuff? Since we have a quiz today, I don't mind going over any concept. Actually, I might just do that separate. I'm going to end this video here and just link it to that homework. So.